Curious to see how Azure Digital Twins can be used to make smart buildings smart? Today, we have Fanie on the IoT show to show us and demo a platform called EdgeNext that his company is working on. Don't miss that one. Hi, this is the IoT show. Thanks for watching. I'm Olivier, your host. Today, we'll talk about EdgeNext, which is a platform that powers smart buildings and leverages Azure Digital Twins. And for that, I have an esteemed guest, which is Fanie. Fanie, how are you?
I'm very well. Thank you. And how about you?
I'm fantastic. We're just joking about the fact that I did press record because we started the first version without it. But now we are recording. We're all good. So, Fanie, tell me about yourself. Who are you? What is EdgeNext?
My name is Fanie Reynders, like you just mentioned, and I work for a great company, EdgeNext, where I am the head of technology, which is like the VP of engineering for the US folks. And we actually power smart buildings, or actually rather, we power buildings to make them smarter and give you actionable insights to make buildings count into your favor.
Nice. And so, as I understand, well, one of the reasons you're here is because you're using some of our technologies, as we'll see in that nice architecture diagram you'll bring up. And one of them is Azure Digital Twins, which is a recent service from Microsoft that allows building these applications or makes it simpler. And actually, you know, from your standpoint as a developer using the service, I'd be curious to know, what is it that you find interesting and what helps you in using Azure Digital Twins for your solution?
Well, when I joined EdgeNext a year ago, this is the initial time I got into the whole digital twin space, I realized that the power that it brings to a platform, it really helps us to accelerate our development by enabling bring your own device capabilities, for instance, but also furthermore in the future bringing simulation possibilities to our platform. And then with the newer version that was recently launched, that just opened up all these kind of possibilities to kind of help us accelerate even faster.
Nice. And is it fair to say that basically all the things that Azure Digital Twins does, you could have done, but this is becoming a bit of a commodity, right? Like being able to put all that data together and actually leveraging a service that you were saying can scale allows you to go faster and also focus on your value add, which is your understanding of smart buildings, of the different technologies involved, and not have to focus on the plumbing, which is underneath. Which is managing the data, which is putting all these things in relationships, and do all of that at scale. So that's a statement, but I guess you agree on that, right?
Yeah, absolutely.
Fantastic. So how about we actually look at EdgeNext as a platform? What is it built off and what is it for? So that people realize a bit better. When we say smart buildings, it's kind of vague. We'll go deep into examples of how EdgeNext platform actually works. Drive me through that. Tell us all about it.
Yes, definitely. I can actually show you. So EdgeNext really is built on 100% in Azure, and having digital twins, Azure Digital Twins rather, just having a small part of that doesn't mean it's not our core. It's absolutely at our heart of our platform. The cool things about Azure Digital Twins, though, it's an eventing system. So let me take you through the whole journey of what we do. So EdgeNext not only powers edge technologies buildings, like in the past it was very much tied to the edge buildings that we built with our holding company, which builds sustainable buildings, by the way. We recently actually disconnected it from those buildings, and we can now cater for any non-edge buildings, so your brownfield buildings, so to speak. But like a box of chocolates, any buildings will open up a lot of possibilities, right? So we need to turn to a platform that will cater for all our needs. As you can see, a building has a lot of things inside of it, but mainly our platform targets three kinds of users, which is our tenants, our owners, and our facility managers. And typically, having that, other entities are also involved, like your sensors, your BMSs, your building management systems. You have digital displays, and also you might have device vendor clouds into play. So the ecosystem of things in this IoT world needs to now interface with the platform. And if we quickly look at how the interface of the data flows into our platform, right? It typically goes from the building, normally from the environment outside, or it can be from inside. Like I said, so they all go to sensors or they go to the vendor clouds. And they typically enter the platform in two ways. In the AMQP protocol, like a push protocol with IoT hubs, or a pull protocol that we have connectors for, that we pull it from the third-party clouds. But typically, they all ended up in one unified ingestion pipeline. Now, in this ingestion pipeline, nothing changes. So it's the raw telemetry that comes in from the building. And then we want to do kind of a few things here, because a building typically generates an immense amount of data, sort of like 22 million messages a day. You might want to kind of do some validation on some filtering on that. Otherwise, you will get like DDoSs downstream. So what we'll do is we'll actually put it through like an ingestion pipeline, which will take care of your filtering, your grouping, for instance, your validation, and most importantly, your mapping, because these devices that send stuff is really much like different structures, different formats. So our ingestion pipeline takes care of those things. When it all passes those tests, it all ends up in our source of truth, which is Azure Digital Twins. Now, like I mentioned before, this system is an eventing system. And the sensors that we have that comes in is actually modeled inside Azure Digital Twins as twins. So when we map it to those twins on the lowest levels, events started bubbling up so that we can propagate these things to rooms and to floors and to buildings, right? So that's kind of how it streams. So the event hits, so it's a pop-up mechanism in Azure Digital Twins. And then you have a number of subscribers, one of which is our little space updaters. For instance, if you want to have a thermostat that comes in with a temperature reading, you want to maybe update the ambient temperature of a room. So that will go to the space updater in itself, and it will kind of loop around and create another event out. Other things that we might have is other systems like the egress streaming that we typically would use for real-time egress to our external clients, using any like a webhook destinations or service bus destinations, even the Azure Digital Twins destinations, that we also connect them with the real-time push of data. What we also do is for our own data exploration, we use Custo, which is Azure Data Explorer. And then for our cold storage, we just make use of Azure Data Lake, where the data curators kind of just puts the data into the formats we need for later on processing. And then because we need to kind of share all these information with our customers, we are making use of Azure Data Share to facilitate and synchronize the customer's data to their tenant in Azure.
Yeah, still preserving their privacy and any kind of IP that they might have in that kind of data, right?
Exactly. So these kind of three pillars, the egress streaming, the Azure Data Explorer, and the Azure Data Share, actually forms part of our API ecosystem, which is governed by the API management that we expose to the clients. We actually give them this one pane of glass to interface with their system, with their data into their terms, right? Just going downstream, so we have these hourly aggregates in our portal. So I'm not talking about the like raw data stream that comes in. We have these hourly aggregates that we analyze data and give like the actionable insights in our portal. That flows down from the data lake into a SQL warehouse that eventually ends up in a data model in Power BI embedded that we now represent in the Azure in the EdgeNext portal.
Got it.
Some of these events also can reach the portal in real time, like notifications and all that kind of things. But the great thing is what we use this whole eventing system for as well, like I mentioned before, is the digital displays, which is a thing that we're about to actually make commercial in a few weeks' time. So for that, we have this kind of real-time projector that is using, at the moment, it's using Azure Durable Entities to kind of keep track of all the kind of displays. And then with the use of Azure Signal R, we push that data to the digital displays that ends up full circle back onto the displays of the building. So that's in a nutshell, the whole thing, how the data can flow.
I like that. That's very interesting. And what I like to point out is the fact that It's not all about, and you mentioned that already, it's not just all about greenfield with new devices that have new capabilities to send to, in that case, an IT hub for ingestion. Is you can leverage existing established solutions for devices that used to be connected using LoRa, using Modbus, using other networks, and eventually collect the information from a third party. Because, you know, in these buildings, it's not just one installer, one type of devices that you have in there. So I do like the way you're basically, you know, mix and matching data from different types of devices, and not everything is about the greenfield aspect of things. So the other thing actually is the fact that digital twins is kind of center to the whole solution,
Yeah.
as in, you know, it represents all these things in the data and then allows you to implement that graph on top that has the logics on all of that. So that's a great illustration of the power of Azure Digital Twins. I like that. I noticed that the displays themselves are not represented in Digital Twins. Is that intentional, or is it something that will end up being part of the Digital Twin story as well?
Yeah, before I answer that question, you're absolutely right. It's not actually in our current design at the moment, or our production version. And I'll tell you why at a second. But, you know, let me just quickly change gears to show you our ontology.
Yep.
So we have this whole building, floor, and room ontology, like a typical building.
Yep.
But typically, and also a device has sensors, but, you know, a building, floor, and room also share that capabilities as sensors, right?
Mm-hmm.
But these sensors, like your thermostats in a room, they could be 3 or they could be 4 in a room. Those could be sensors for a room, but it also could be part of a device, the sensor. But on the room level, you typically also have one metric for those 4 sensors. Like, think about your ambient temperature. That is not just one value of the thermostat, but it's the collection of those values, the aggregated value for those for all those sensors together. And that in itself is also the building, the floor, and the room is also sharing that metric in itself. And to kind of go back to your question is, at the time when we built the digital signage, we were still kind of in the migration period between the V1 and the V2 of Azure Digital Twins, and we actually opted in for a lift and shift, and then later on a re-architect of our ontology. So when I go to the next slide, you will notice that you know, typically we will have the ability to later migrate off of, let's say, Azure Durable Entities into actual Azure Digital Twins, and it will still have the same implementation.
Nice. I see. Nice. Well, so that answers the question. It will end up being part of the digital twin story as well. I like that. So now, Fanie, I think would like to see it in action, right? He's talking about digital signage that will actually be notified with some information. So I think you have a little demo for me here. So let's look at that, right?
Yeah, cool. So what you actually see on the screen right now is typically our digital displays. These are 2 of the displays that I just brought up. It's
These are web interfaces, right? This is what web page that basically the smart display of the digital display actually is digital signage. Sorry, is just pulling from.
Exactly. So we don't provide the narrowcasting solution. We provide the content for the narrowcasting solution. So that's given that whatever this is displays at least needs to have a kind of a browser or able to go to a URL. So that means it's super portable. It can run literally anywhere, on your fridge even. You know, that's a good. But so these are the kind of 2 typical use cases that we have. And what you're seeing here is basically CO2 levels and comfort levels for instance, for a room. And for when COVID hit, there's an actual kind of a safe level for COVID-19. It's below 1,200 ppm, parts per milligram or something. So we have this kind of dial in the rooms, and then as the carbon dioxide changes in the room, so it's aggregated room level data. As it changes, these dials and these colors changes in real time, and it's super important, and also for the safety of the people inside of that, to know when is it good to be inside and when is it good to actually leave the room, right? So it's very important to have these displays working, right? So going back to the actual digital twins, I actually want to point out, you know, our 2 ontologies that we have running. The right hand side is the V1, and the left hand side is the V2 that we're actually having on currently, just to kind of bring you back to that point.
And they're living side by side as well.
They're living side by side, and that's the point. And that's a cool thing about Azure Digital Twins, as it's you don't need two database instances or something. You can use the same thing because all of these things are versioned. Each twin, the schema is versioned, so you can actually seamlessly migrate to the next version and have backwards compatibility on your twins.
Without breaking anything in production.
Yeah, that's well, given that you tested it, right?
Well, you test, obviously, you test before, but you don't break things, right?
Yeah, exactly. So that same, so this is a typical database, a typical building that we have in our production environment. And this is a representation of it in our digital twins. Starting from top, we have our building, and then we have a floor. And then a floor, in this case, it has footfall, people in, people out, and some people count scenarios. And then we have a room. And a room has these metrics like this, like a temperature, humidity, usage, and the carbon dioxide metrics. That's the aggregated matrix. And then these are the sensors I was talking about. So typically there are two devices, as you can see on the bottom here, with each device has these, is it like 4, 5, 6, 7 sensors each. And this is typically the whole, like a sample building for this demo purposes, but this is a typical building's kind of ontology or topology rather in a digital twins. So what I can actually do is, because I'm not going to be in a building right now, there's no one there, but to simulate, maybe alarms and stuff that can go off, like I can actually go to a twin, using this special explorer, and I can modify one of these sensors. So typically also you could use the IoT simulator on the IoT app, but you could also go into the Azure Digital Twins Explorer and pick any one of these devices. Because the digital signage displays works on space level, it doesn't really care which device you use, as long as the ambient temperature, is calculated correctly.
Yeah. So, and what like you mentioned, the fact that digital twins was good for simulations, and actually that's exactly what you're doing. You can simulate a critical situation to make sure that all the other systems are reacting like they should, right?
Yeah, exactly. So let's simulate a critical system. So this is now a normal situation. Yep. Let's say you and me are in a meeting room, and all of a sudden there's an increase in carbon dioxide. So let's kind of simulate that scenario. So we do that by kind of going to a sensor, and on the right-hand side we can see this property is popping up. And I do want to point out that this Explorer is typically used by your internal staff, not being used by a customer. But it's a great tool to also kind of navigate your twin without, writing special code for it. So let's do that.
While you're showing and saying that, I want to point out as well the fact that the access to that twins data actually is restricted, right? Everything you can access the data and go change it because you're like top admin, and you're leveraging Active Directory and others, yes. Features. And because it's a cloud service hosted on Azure, you can actually just layer on with your own AD tenant and be sure that you don't have someone randomly go and change these values there.
No, you don't want that. So I'm actually a contributor on this instance, and that will allow me to kind of make these changes. If I was a random user, obviously I cannot even log into this Explorer because it's, like you said, it's integrated into AD. But our applications in itself, so if our application needs to change the state, like the space updater, for instance, there we use manage identity. So it's the identity of the application and not even a service principal or some username. We actually have the identity of the application that has access to the digital twins instance.
Yep.
Right. So let's rogue these values up. So normally say values is below 1,200. So let's actually make them 1,800. Okay, that will actually go. Let's make 1,900. I think that should work. If we go, for instance, now to a newer timestamp, and we update that, then you will typically see that in a few seconds that the telemetry will start to change, right? And this is what we want to see. So this is like, hey, go get a coffee.
Yeah. Yeah, exactly. Let's get out of here.
Get out of here. So exactly. So, and why is this important? So not only do you get drowsy, but also when you are sick, and not just COVID or anything, it higher the risk to get infected by another individual in the room. So also we really want to get our employees back to the office or more welcome at office in these kind of pandemic days. And tools like these really help us to kind of facilitate and make people warm and fuzzy about going back to the office.
Yeah, that's pretty powerful.
Yeah, that's actually awesome. So what we're also planning to do is this solution that you see right here is not commercially available yet. It will be commercially available for our customers in the coming weeks. But what we also want to do is bring these tools, because I mean, obviously we have these displays and stuff very much caters for certain use cases. But we want to bring the developer tools to the customer's hands so that they can also author their own displays as long as they use our SDK on the back end and as long as they use the API on the back end. They can go wild and free and implement it in Vue.js, React, Blazor, for instance. Any technology they want, it's on their terms, but it's their data.
Love it. Love it. And just powering everything in the back. Love it. Okay, Fanie, there was a very nice demo of the use of digital twins for smart buildings with the EdgeNext solution. If people want to learn more, there's a nice blog post that's going to be on the tech community sites at aka.ms/IoT show/EdgeNext. Fanie, thanks a lot for your time, and I hope to see you soon. And everyone, thanks for watching the IoT show. Bye.
Thank you. Bye-bye.